So exercise 2 looks a little bit different than the first one. Instead of given a certain number of things and told how many are in a category, right, damaged, figured damaged, we're told that 40% of all calls into a department can be fixed by rebooting the machine. We still have that sampling piece because we're told that suppose 4 calls are randomly screened. So there's our sampling. First question becomes, is this a sampling with or without replacement question? Now, technically, it's without replacement. I'm not going to screen the same call twice. However, they didn't give me a number of calls that I was looking into and taking from, right? So there's this sort of infinite idea of like an infinite number of calls. So because of that, this is going to be a sampling with replacement. And one easy way to make sure that you recognize that is anytime you have a percentage as opposed to those hard numbers, we're definitely dealing with a sampling with replacement sort of situation. So let's see, I have all the different questions I could possibly ask you as a sampling question that come after this. So this is a really good practice problem in terms of making sure that we've seen every single question I could possibly ask about sampling on the exam. So again, we're sampling 4 things, and then we have our different questions I could ask. The first one says all of the 4 calls can be fixed by simply rebooting the machine. So recall what I said last time in exercise 1. If we're selecting 4 things, that means we have 4 different random events that are occurring. And in this case, we want all of those 4 events to be fixed by simply rebooting. So let's just go ahead and say, well, that means the first one, second, third, and fourth, they're all fixed by rebooting. And then again, just like before, we're going to figure out all those probabilities. Instead of doing a giant tree diagram with 4 splits, which is going to be humongous, we're going to use this notation. It'll make life a lot easier. So what's the probability the first call is fixed by rebooting the machine? Well, that's our 40%, right? Second call, still 40%. This is why we can kind of treat this as a sampling with replacement issue. There's nothing that says one randomly selected, right? Randomly selected call is going to influence whether or not the next one is also fixed by rebooting the machine. So that's why we can keep this 40% each time. We don't have to worry about that sampling without replacement where we change up those probabilities. So third one, still doesn't matter that the first 2 were fixed by rebooting. They're all randomly screened. And the fourth one. So this is just going to be 0.4 to the 4th power, which is 0.0256. All right, so you guys try to set up the next one. Or pause if you're really brave and try to do all of them. All right. So the next one says none of the 4 calls. So we're still dealing with 4 random things, right? Every single one of them is going to have 4 random things. But now they can't be fixed. The first one is not fixed. Second one's not fixed. Third one's not fixed. And the fourth one's not fixed. And all we have to do is use our complements. If 40% can be fixed by rebooting, that means the probability of it not being fixed is 60%. And just like the last one, they're all 60% because they are randomly screened. So we get 0.6 to the 4th power, which is 0.1296. All right, the next 2 are a little bit more trickier. The next one, C, says that at least 1 can be fixed by rebooting the machine. So here's where students will get in trouble, especially if they try to do this little notation stuff, because that means 1 could be fixed. But it also means that 2 could be fixed, or 3 could be fixed, or all 4 could be fixed. And that's a lot of different outcomes, right? So this is actually going to be a giant pain to do this way, because not only do I need to figure out 4 different probabilities, I'm also going to have to think about how many ways those 4 probabilities could happen, which is a giant pain. But here's the better way to think about that. Let's just do this almost as a discrete probability question, right? Back to that distribution. So the number that could be fixed. We had none, which is 0. 1, 2, 3, 4, which is our all, right? And in this case, oops, what we care about with at least 1 would be all of these probabilities. As I said, I would have 4 things to calculate, which is a lot of pain, a lot of work, and have to add them all together. Or I can use complements. The opposite of at least one, all of this stuff, is none. So that's just a kind of like a trick here. Probability of at least one is just 1 minus the probability of none, which we already have, right? So we end up with 0.8704. The next question is similar. This asks about not all. So all by itself would be this. Not all would be all of these things added together, which again is a lot of work, but it makes more sense to just do this. Since not all is the complement of all, and we've already done all up in part A, we're just going to subtract off that value. So that's the one way these can be a little more trickier, is that I could ask one of these, the C or D version instead, and that means you have to not only do A or B, but then you have to realize it's a complement. The last question here is exactly one can be solved by the rebooting the machine. Back to our little table, exactly one is just this. So this is one we have to calculate by hand, right? And so we'll go back to our little slots, our different events that have to occur. 1, 2, 3, 4 things are still being screened. We never get to change that. It's a very common mistake because students don't always keep those 4. And we only want one to be fixed by rebooting. So let's just go ahead and get that first, which means the last 2 or 3 cannot be fixed by rebooting the machine. And we know these probabilities. 40% are fixed by rebooting, well 60% are not. And since these things are all just independent events, they're going to get multiplied together by the independent rule. The only thing that changes here is, unlike A and B, there are different ways that this could happen. If I made up that entire tree, there's actually 4 different ways to get one that fixes by reboot. This could happen in the first slot, the second slot, the third slot, or the fourth slot. So we need to multiply all of this by a 4 out in front. I think that's the part that students struggle with the most, is when do I need to multiply by the number of things and when do I not have to do that. And the one thing I'll say is just be very cognizant. It only is true for when we're looking at a 1 success versus the all or none. You'll never do the multiplying by. So anyways, there's our answer for part CE. I hope I didn't screw that up.